Hey everyone, Rusty here at Blue Robotics. Today I'm going to introduce you to the BlueROV2 and show you some of its cool features, particularly those added in the most recent R4 revision. The BlueROV2 is a remotely operated underwater vehicle with a camera, lighting, and thrusters that allows you to explore, inspect, and study things underwater. For the purposes of this video, I'm going to assume that you already know what an ROV is, and I'll focus on the specific features of this ROV. Let's get into it. The ROV frame has 2 side panels, a bottom panel, and 4 center panels, creating a rectangular structure and providing places to mount the enclosures, the thrusters, the buoyancy, and the ballast. This design is inspired by work-class ROVs, which typically have a similar structure, allowing things to be easily added to the ROV for different missions. You can attach just about anything to this frame. At the top of the frame are these blue fairings, which hold polyurethane buoyancy foam, used to give the vehicle additional buoyancy. And on the bottom here are stainless steel ballast weights. They can be added, removed, or moved around to balance the vehicle and to maintain neutral buoyancy based on what you have installed. The buoyancy on the top and the ballast on the bottom makes this vehicle statically stable, meaning that when it sits in the water, it always wants to sit upright and stable so that you've got a solid camera view and a stable platform to hold any sensors or equipment that you're diving with. There's 6 thrusters in this standard configuration, and there are 8 thrusters in the heavy configuration over here. On the standard, there are 2 vertical thrusters on the top here in the middle, and on the heavy, there are 4 vertical thrusters. Those vertical thrusters help you go up and down. And then there are 4 thrusters on the bottom in what's called a vectored configuration, where each of these thrusters is at roughly a 45-degree angle. The thrusters themselves don't rotate, but by varying thrust on each thruster, you can create a thrust vector in any direction. That means you can drive the vehicle forwards, you can drive sideways, or you can drive at anywhere in between, like off to a 45-degree angle. This configuration is ideal for driving in real-world conditions where there's often currents coming from different angles and you want to move the vehicle sideways as you inspect or view a surface. At the center of the ROV are 2 enclosures. These were both updated to our improved locking enclosure design in the R4 version of the ROV. On top is the electronics enclosure, and down here on the bottom is the battery enclosure. The electronics enclosure has a camera at the front with 1080p high resolution and sends a live, low latency stream up to the surface for the pilot view. Behind that are the rest of the electronics. Right here is the Navigator Flight Controller running BlueOS, which is also a new improvement on the R4 version of the ROV. The Navigator consists of a Raspberry Pi computer with an array of added sensors, inputs and outputs, and expansion capabilities. It uses its onboard sensors to determine the attitude and heading, and outputs to the thrusters to automatically stabilize and control the vehicle based on pilot inputs. The ROV runs on our BlueOS software, which encompasses a number of different elements and is open source and user modifiable for your application if necessary. BlueOS manages the operation of the vehicle, including that RG-Sub control system software, the camera, the communications through the tether, and it has expansion features to support other sensors, sonars, and payloads. The Navigator connects to the Ethernet network that connects the vehicle to the surface and forwards the video stream and controlled data to the topside computer. It's connected to the Fathom X tether interface board, which transforms that Ethernet connection into a long-range connection over just 2 wires. And last, there are 6 speed controllers mounted at the back, connected to the thrusters and to power. On the outside of the enclosure, at the back, are cable penetrations leading to the thrusters and lights, as well as a pressure and temperature sensor, a pressure relief valve, and several blank penetrations for expansion. Below the electronics enclosure is the battery enclosure, which holds a battery during operation. The battery typically gives you about 3 to 4 hours of operation in normal conditions. Starting with the new R4 version of the ROV, you can choose either acrylic plastic or aluminum enclosures. The acrylic enclosures are rated to a depth of 100 meters, and the aluminum enclosure increases that to 300 meters. The tether on this vehicle runs from the vehicle to the surface. This particular ROV has a pretty short tether that can be managed by hand, but we have tether lengths up to 300 meters, and we have an optional tether spool to manage those longer lengths of cable. At the surface, this cable plugs into the Fathom X tether interface, or FXTI box, which has a connector for the tether and a USB connector to go to your laptop computer. Once you're connected and powered up, you connect to the vehicle using the Q ground control software. That one's also an open source software application, and it runs on Windows, Linux, or Mac and provides live video stream, live data view, ability to adjust the parameters on the vehicle, and an interface to any gamepad or joystick controller to pilot the vehicle. The BlueROV2 requires some user assembly. When you first get it, the electronics are already wired up and tested, but you're gonna have to put the frame together, mount the thrusters and enclosures, and get it connected up to your computer. It usually takes anywhere from 6 to 8 hours to do that, and it's a really fun process that'll leave you knowing a lot more about the ROV and how to work with it. Today's video is just a quick overview, but we have a lot more information available on the ROV. If you're interested in that, I recommend checking out the technical details on the product page, as well as the assembly, software setup, and usage guides. You can also ask questions on our community forums, or you can check out our YouTube channel and social media to see what other people are doing with the BlueROV2. If you do get a BlueROV2, you're going to be joining a community of literally thousands of users around the globe who are exploring the underwater world and pushing the boundaries of marine robotics. We really hope you'll join us in that. That's all we've got for today. Thanks for watching, and see you next time.